A very good morning once again if you're just joining us. Now, today is the World Hepatitis Day. A lot of us don't understand what hepatitis is, but it's one of the biggest killers in the world, with over 170 million people estimated to be suffering from hepatitis. Out of those, an estimated 1.5 million people die every year from hepatitis. And this country is one of those countries that are suffering the scourge of hepatitis. This morning, we joined in the studio by somebody who is very significant, an award-winning scientist, a chemist, who was on Friday awarded by the Mount Kenya University with an honorary degree in pharmaceutical sciences. Dr. Njoroge, karibu.
Asante sana. Thank you very much. Yes, my name is Dr. George Njoroge, and I work with Eli Lilly and Company in Indianapolis, Indiana. I was a director of research at former Sharing Proud Corporation, which was later bought by Merck Company. And in Sharing Proud Corporation, that's where my group, which I directed, discovered a major drug in treatment of hepatitis C by the name of Hepatitis. Hepatitis is an oral drug that treats hepatitis C and cures.
Tell us, let him tell us hepatitis, what is it? How does it mean?
Okay.
So how do I know I've got many? And what is the difference between A, B, C, and
Okay.
Yes.
Okay. Hepatitis is a viral disease. We have hepatitis from A, B, C, and there are other smaller hepatitis, D, E, F, and J. But the major ones are A, B, and C. This is a viral disease. A virus is an agent which can replicate just like human cells, but it doesn't have the genetic material equivalent to human cells. It's on the lower level. The higher level is the bacteria, and then you come to eukaryotics, which are the new human cells.
I'm sure Mutegi is floating in all these things, like every one of our viewers, with this scientific jargon.
Okay.
But let's bring it down to the ordinary person. When somebody suffers from hepatitis, where do you ache? Where do you feel? How do you feel?
Okay. Now, let me concentrate a little bit on hepatitis C.
Yes, which is your area of
Again,
research.
as I said, hepatitis is a disease that's caused by a virus. Once you have it, first of all, hepatitis C is a tricky disease. We call it a silent disease. You could be having the virus without knowing, and you can live with the virus for even 20 years. But once it becomes active, it proliferates and attacks you very quickly, and it can kill you.
Yeah.
The way you know that you might have it,
Yeah.
usually mostly it's through screening. When you go for other tests and it's screened and you're found to have one, major indications are very mild because it's either fatigue, muscle ache, very mild symptoms. That's why it's a dreaded disease, because a lot of people have it.
You may not notice you have it.
You might never notice that you have it.
It eventually settles somewhere and attacks your, is it which part of your body? The
Yes.
liver, or is it where does it settle?
Okay, once it attacks a human being, it goes to the liver, and that's where it causes swelling, or what we call inflammation.
Inflammation, yes.
And it can go in an acute, meaning a quick effect, or it can be chronic. It can start the multiply slowly for a longer time, whereby even after 24 months, you still have the virus.
That is hepatitis C.
Yes.
But there are other hepatitis.
Right.
There's a hepatitis A, let's look at that, and then B, and then C and D.
Right.
Those are the principal hepatitis
Right.
elements. So
Right.
you've talked about C, the silent killer.
Right.
Let's look at A and B, and perhaps D.
A is more acute. It attacks you very quickly. And A, B, actually, it's a good thing because we have vaccines against those.
Okay.
C is a more complicated one. There is no vaccine
At
for
all.
C.
And that is why your innovation, your research led to Vactrelis,
Right.
which is now a frontline therapy for it.
Exactly.
Yeah, but in terms of people feeling, we are suffering from hepatitis out there.
Right.
Is there a distinction between, if you are suffering from hepatitis A,
Right.
which you have not described yet to my satisfaction,
Right.
and B,
Right.
How do you feel? How do you know before you even go to a doctor
again,
that you could have A, you
right.
could have B? What are the
that will only
the
come
symptoms
from the screening, because again, we cannot go to the scientific
there are no
jargons
symptoms.
because there are no symptoms. Usually, it's the screening, and they look for the antigens,
Yes.
which will tell them whether you have the A, the B, or the C.
Right.
And that's why it's a it's a tough disease, because there has to be some screening done
To tell whether you have
identify
it.
what there is. And you've seen in the media saying that the governments are trying to initiate these efforts whereby when people go for other type of screening, for other physical evaluations, they will check for that, because
Hepatitis.
if you wait until you see the symptoms,
It will
it
be
might
too
be
late.
too late.
Okay.
So, and finally, it ends in the lungs?
In the liver.
The liver. And nowhere else?
Mostly it is in the liver. That's
And the liver
difference.
swells.
The liver swells.
Whether it's A, B, or C. So,
Yes.
the liver.
Right.
It's a
And
liver disease.
it's a liver
let's
disease.
Let's call it
Liver
that
disease.
way.
That's
And
what we wanted
eventually
to
what happens, it will go slowly. It depends on how quickly it becomes active.
Yeah.
And the liver starts swelling, then you go to what is another stage, which is called cirrhosis.
Yeah.
And then the liver starts, blackening, and it can even advance to even the more difficult step, whereby even it becomes a cancer.
I
Right.
thought cirrhosis was associated with alcohol.
Yes,
drinking.
it is, but it's also associated with other things.
Yeah.
And that's why.
In fact, then, Dr. Let's look at what are the potential causes of hepatitis, all forms of hepatitis.
Right. Well, viruses are very interesting creatures. Viruses is just like what you get when you have a flu,
Yes.
influenza. That's a virus. We have Ebola virus.
Yes.
We have HIV is also a virus.
Yes.
A lot of these agents, they just appear. Like Ebola, you hear it appeared and disappeared. So there are agents that are there, but nobody knows the mechanism why they appear at a particular time and why they disappear at particular times. We know that they are there and they cause diseases.
Right.
So when they come,
Yeah.
we know how, we have to figure out how to get rid of them.
It is not a disease that is attributable to a certain lifestyle or consumption patterns, like the way people, liver diseases, diabetes, people attribute them to certain causes.
No, this is not more of a lifestyle. The only part I can say, people contact it through a couple of ways.
Yes.
One of them is, the major one actually, is blood transfusion. When
Yes.
people get blood transfusion, that's
From
if
somebody else into your blood.
Yes, and
Yeah.
that's why they have to do proper screening of blood that is transfused to another patient, to a patient, to make sure that it's not infected with hepatitis. The other ways is people who use needles, for various things,
Yes.
and they exchange those needles. That's another aspect. Sexual activities also cause it to some extent.
It's transmitted sexually as well.
Yes, it is.
Yeah.
So those three actually are the major components.
Yeah. Interesting. I mean, the reason I'm pursuing that line is because obviously, are we more vulnerable, say, as a community, to hepatitis B? I mean, this is one of the bigger killers. We have seen cancer, which has really taken a lot of attention in this country, and a lot of people have died from it.
Right.
Hepatitis B, hepatitis generally also is quite a killer. I mean, ranked perhaps among the top, is it here,
Right.
7 or
Right.
so killers.
Right.
Are we more vulnerable? Are communities more vulnerable? Is it regional? Like if maybe America, it's less. It's more here in Africa or like that.
Right. Well,
Prevalence.
I don't think we can say it's more prevalent in one area than the other. It depends on what type of activities are going on in one place than the other. If in a community, let's say in a country where the blood screening is not done properly, you will have it more prevalent of this hepatitis taking place. And if it's A and B, where people don't go for vaccination, then of course it will be aggravated.
Yes.
So, but C, which is now becoming, C infects about 150 million people worldwide.
150 million people.
150 million people are infected with hepatitis C. Now, that's a high number. However, not all of those will go to die from the disease. Because, as I said, it depends on what stage the disease is.
detected.
Most of them will live maybe for 20 years, 30 years with the disease without having any effect on them.
Yeah.
But there is that percentage, you know, that will go and the virus become active. And that's another question you're going to ask me. Why does it become active?
Yes.
Nobody has an answer for that.
You're still researching it.
Yeah, that's something we need to do research on.
Yeah.
But when it becomes active,
Yeah.
it moves very fast to the second, third phase, and even to the chronic and the phase that will...
Now let's look at
killing.
detection. That also calls into question facilities,
Yes.
laboratory infrastructure, and so
Right.
forth. I mean, you are of course based in the United States, where
Yes.
things are sophisticated.
Right.
Are countries like Kenya able to detect these things early?
I think, yes, I've visited
your
places
assessments?
like Kemri, and I think they have the facilities that are capable of doing that. I don't want to go again into the sciences. There are
Yeah.
kits, that ELISA kits, you can use ELISA methods where you can detect the viral load and know how much of the virus the individual has.
Yeah.
And so those, but you know, one has to be careful because you have to use some of this virus to detect, because you need to detect them at the very, very low quantities.
Yes.
So that when you can detect them, you can maybe give the medication before it, you know, exacerbates, you know.
Yeah.
And that's a problem. And so one has to use the proper system so that you can catch them at
But I
very...
think
So
again,
what you are saying is that people need to be tested.
Yes.
Which it doesn't happen.
Whenever you go...
That's the difference between
exactly.
us and America.
Right. And now there's a campaign even in America. We were there even actually as far as maybe 2-3 years ago. America has a big campaign right now telling people when they go for other physical evaluations, they ask their doctors whether they, you know, whether they should do the test for these viral diseases, especially hepatitis C. B and C also, because people might also have some vaccinations. That's not as bad, but C is also pretty serious.
But people here get vaccination for polio. There is a big campaign for fight polio.
Right, exactly.
Why
Just
not,
like they
why,
do that.
Why not hepatitis?
Well, that's the thing. People now have the realization that they need to do that, so that awareness has to be there.
So the polio can be eradicated from the world.
Right.
It is in the process of being
Right.
eradicated.
And that's a good thing. With
why not hepatitis?
hepatitis also can be eradicated.
Can it be eradicated?
It can be eradicated. And that's a good thing about the science that has been done now. Hepatitis, even let's say hepatitis C, when it's cleared, when you are given the right drug, you can cure the disease.
Can it recur?
As opposed to something like HIV.
Can it recur?
It depends whether it was treated properly. If you don't take the whole dose to take you all through, and if there's a little bit left, yes, it can recur. But what they have a system to check. They check every 24 months and see how your situation is. And there is a way of giving you such a time when they can declare that you are completely free of the disease, when they do multiple tests thereafter, you know, after you stay, after some time after being given the drugs that are available.
And tell us the process under which you made that, or you discovered, or you invented, or whatever, that drug that you have for hepatitis C.
Okay.
What does it involve?
Okay. The drug that we discovered called Victryris, it took about 16 years to discover the drug. And what we had to do is...
When you say discover, means what? It was hidden somewhere, you saw it.
I've gone through research methods.
Yeah, because if you say you discover,
try this other,
What do you mean by
against, as an
discover?
antidote against...
That's a good question.
Yes, yes.
Because it makes people appreciate what we do.
Yes.
In the drug discovery, we try to understand what this organism, I'm going to try to be as basic as I can.
Yes, yeah.
We try to see how this organism moves. And organisms have mechanisms that they apply in order to multiply themselves. They use things called enzymes. And those enzymes, they can turn them on and off when they want to multiply or when they want to stop multiplying. So we as scientists can go and look at that enzyme and try to see how we can turn it off by making a molecule. Just like we make aspirin to stop a headache. We can make a molecule in the lab that will stop that. So this molecule, we found one step that the virus is using to multiply in billions, actually in trillions, within several hours. But when we found out that step, then chemists came together and thought it's just like a key in a lock mechanism. When you put a key in your lock, you open the door. But if somebody comes and jams that, puts a plug of, let's say, a metal there, and you come with your key, you cannot open the door. So we try to make a molecule that looks like that blocking stuff there, and we block that. Therefore, the virus cannot multiply. And to do that, you have to make a molecule, test it, see whether it works. If it doesn't work, make another one. So in the discovery of Victrelis, we made about 5,000 molecules. And only one of them was able to do the magic. It was that one of them succeeded. And that's the one that went to the market. Because the fact that actually it stopped the unlocking of the door or the unlocking of the viral replication does not necessarily mean it's a drug. You must also make sure that it gets into the blood and it's not metabolized, meaning chewed up.
Yes.
It goes to where it's supposed to work and does exactly what you needed to do. So all that process, plus the fact that once we start with in the test tube, we go to the cells and go to the higher species. Once you get all that, then you go to clinic, where you get the clinicians in hospitals testing it on with the people.
Yeah.
So it's a long process.
So this whole process of discovery of Victrelis took
16 years.
16 years.
Yes.
Because it was finally accepted by the Food and Drug Administration in the U.S. as a drug in 2011.
Yeah, May 13th, 2011.
2011.
Yes, and we started in 1995.
And from what I've just read statistically, it has gotten a lot of global application, administration, and made a lot of money. So who owns the patent for that drug?
Oh, okay, that's an interesting question.
If it's done already, it's done already 10 billion shillings.
Yeah, we were
dollars.
Off the camera, we were discussing about this because some people come and tell me you must be
very rich.
You must be rich because you have been honored with its discovery and your team.
But that's not true. What happens is, in this discovery, as I told you, the institute I was working for, Sharing Proud, is a private company, and its business is making medicines for sale.
Yes.
The stakeholders are shareholders who invest in this company. They want a return from this company. So they employ several PhDs, masters and BS, and several other people in other fields to discover medicine, which they hope at one time they'll get back their money. So
you are hired as a professional researcher with
yes.
a business of discovery, inventory,
Yes.
and exploration.
Right.
But what does the inventor of the drug, what royalties or come to you as the scientist?
Right.
None at all.
Right. Well, I wouldn't say none at all because
in the nature of
all those 16 years, just like you guys are here in Citizen, you get paid.
Yes.
I mean, so I was paid all those 16 years.
Yes,
the company was not making anything.
That's what I
from
mean.
me.
But once it's become a drug,
it's theirs.
and it's trademarked, Victrelis, as we see it, and your name is attached to it.
Yes.
There is no other benefit that comes to you
there
as
is
a
a big
researcher.
benefit.
Intellectual property
there is
is
a big
ceded to
benefit.
the company.
There is a big benefit. Or if you go to the patents that have been written, they are under my name with my group. So the intellectual property, because the company cannot think, we are the thinkers.
Yes.
We come with ideas. And so the intelligence comes from us, not from the company. So when we do the patenting, we own, the company owns the patents. But the intellectual, we are the inventors.
Yes, yes.
So in the scientific community, they actually mostly know us because we are the ones who write the publications. We are the ones who write the patents. But the company owns
is the custodian of the intellectual property.
Yes. And the patents normally is something to protect them so that it can give them enough time to recoup the money they spend developing a drug like that.
Yes, yes.
So that's all what a patent is all about. And we as a scientist, actually, we are very happy to see that we've made an invention that people all over the world can see it's a very important one.
Yeah.
Scientifically, we become very satisfied.
Yes, yes.
So that's where our satisfaction
Yeah,
comes.
some friend of yours you went to school with is very happy to see you here. He's called Dr. Ngugi, an old
Dr.
schoolmate
Ngugi,
of
yes,
yours.
yes,
He
yes,
says, congratulations for the good work.
Oh, thank you, Ngugi.
But he says, explain the cost and availability of Victralis.
Well, the cost, I cannot come to that because that is in our business arena. As Gogi would know, I'm a chemist, you know.
Yes.
I'm not into finance.
The pharmacies here
and
might,
I'm always told not to talk about finance because I'll make mistakes.
Yes, yes.
I'll give you the wrong numbers and then people will not be very happy about.
Yeah.
But maybe if you can Google, you will find some of that information.
I'm sure they are this is a drug that's dispensed here and it's available in the chemists and pharmacies here.
Yes, exactly.
What about side effect?
Or side effect, there are normal, one of the side effects, because you take it as a combination of 3 drugs. Mm-hmm. You take it as a combination of what we call pegylated interferon. That's an immune booster to boost your immune system. Mm-hmm. And another genuine antiviral, which nobody understands why it works, but it helps, called ribavirin. So you take it in those aspects, you know, in those combination.
Yeah.
So it's one drug made of 3, or you take 3 tablets?
No, you take 3 tablets.
You take 3 tablets?
Yes.
Okay.
Actually, sorry, you take 2 tablets because the one with the interferon, that's an injectable.
Somebody, questions of course, and you can ask a few questions, you know. Dr. Njoroge is a researcher. He's not a medical doctor.
Exactly.
He's a pharmacist. He's a chemist. Who deals with the drug compositions and administration of those drugs. I see some medical questions coming in. I'm almost becoming a doctor now because of sitting next to him. Somebody says, I'm Helen from Nairobi. My brother had a hepatitis B 6 years ago, and he was treated. Does he still have the virus? Because up to date, his fingers and toes are cracking and black in color.
Right.
So if somebody is treated from hepatitis, I mean, these viral diseases are not curable. Is that the right word to say?
And that's what I was saying before. With the hepatitis, let's say B, C, those are curable. And the people should understand.
The vaccines for A
not only
B.
vaccine, also the mechanism.
Right.
Let me make it clear to our audience.
Yes, important.
Because people are used here with HIV, which is not curable right now. Because the HIV goes and integrates into the DNA. It goes and becomes part of DNA and tells DNA, I want you to make copies of myself. So for you to destroy it, that's why it's difficult. You have to destroy the whole DNA. Yeah. Now, with hepatitis, it's not in the DNA. It is in what we call cytoplasm, the stuff that surrounds the DNA. Right. So if you can put a drug there, it will go and kill any virus that's around there. Right. And if you continue to kill that, after some time you will wipe off all the virons, and eventually you can kill everything. But for that question, what they should do is first of all go back to their doctor, have them assessed again, because it's very easy. They have tools, they have kits that can tell whether the virus is still there. And those take a very short moment to test. So they can test and say whether it's still there. It may be these indications are from a different, from a different disease or from
altogether.
A different
The blackening of the toes and fingers, maybe something else
I
altogether. Those are not symptoms of hepatitis, are they?
No.
Black toes and fingers, right?
That I haven't had.
Because I'm not a medical, it's liver, it's cirrhosis.
It's a liver disease.
Yeah.
And I'm not a doctor, so I think that they should try to see what the doctor would say about that.
Yeah, somebody else asked here, my name is Rosabella. I went to hospital a week ago for maternity clinic, and they tested me and they found that I'm having hepatitis B, but they will reconfirm if I go for results on Wednesday. I also feel pain when I use my right side when I'm sleeping. Is it the baby that is causing the pain? She's 7 months pregnant. Or are these signs of, because she's not seeing any signs of hepatitis.
Right.
Yeah, so she's wondering.
Again, I'm going to put a disclaimer that I'm not a doctor.
Yes,
I'm
but
a pharmaceutical
general knowledge
doctor.
you can.
So I would like you to go to my feeling is, and this is a personal, I'm not giving as a professional I don't think it's from the virus, but they should see their
They should see the doctor.
Yes.
Go for the confirmation or
Right.
review, as they say
Exactly.
in medicine,
Exactly.
on Wednesday, and then you'll get told what
Right,
exactly.
that
it is.
I think would be the best thing.
Yeah, and but also when we were discussing about detecting the disease, you mentioned only the high-end Kenya Medical Research Institute, KEMRI. Do
Right.
you, in your knowledge, are you aware whether our local hospitals, clinics, I mean, are there testing kits for this disease all over the place?
Well, in US, I know there are a number of testing kits, and I haven't gone to the Kenyan market to see what's going out there, other than what I read in the media, whereby they see some disparity, you know. So my feeling is those kits, you know, some of them are expensive, but you know, I think there should be some reasonable kits. But again, I caution, because you need the kits that can tell you exactly what's there, because you don't want to use a misleading
People have been misdiagnosed. I mean, like somebody asked, what is the connection between HIV and hepatitis B? Because some people get misdiagnosed, you are given this for the other.
Right.
Is that really
that
close?
can happen. In America, I don't see that happening at all. There are many cases in the US whereby people have both, actually. HIV people are also infected with hepatitis C.
Yes,
we have quite a number of cases like that, and people could have been using it for the two purposes.
Yes.
But here in Kenya, you know, I'm not very familiar with the system or the
Right. Are children susceptible to hepatitis?
Everybody is susceptible
Even
to
at
hepatitis.
birth, you can have it.
Well, depending on how it was transferred to them. If they were contacted some blood from, you know, maybe there were some needles used, or there was some blood transfusion that was done, then there is a possibility if the blood was not screened properly.
Let's look at research.
Okay.
Your area, because that's really your specialty.
That's my homestead.
Yeah, let's go to your homestead.
Okay.
How are we as a country doing in terms of research? I mean, you're in the US, obviously, a lot of, is there sufficient provision, adequate funding for research, and where should that funding come from? Try to apply it to Kenya, please.
Well, when I look at research in Kenya, people are trying very hard. The scientists here are trying very hard. But my feeling is, and again, this is my feeling, they need more empowerment. They need more support from the government and from private institutions. People should invest in looking for things like drugs. But it's also very important for our researchers to educate the stakeholders what it means to do research, because research is not an overnight thing. We talked about 16 years. A lot of people who invest here, if you tell them it's going to take 16 years, you know, they might shy from coming to you. But the reward is enormous if you get something. Let me give you a good example. There's a drug called Ripetal. For lowering cholesterol. In 2012, that drug sold for about maybe $12 billion. $12 billion. That's equivalent to maybe 900 billion shillings, which is close to $1 trillion. So if we invested on something like that, even if it takes maybe 16 years, you know, that's money that can
come back to the country.
It can service, you know, some maybe all the ministries, and even it can in the parastatals.
So we have KEMRI here. What do you make of it?
KEMRI is doing a great job, but we need more. KEMRI is a government-run or is a parastatal institute. We need investors. Instead of only investing in other things that we invest in Kenya, we need to bring back our scientists. We are very talented people. Nairobi University, MKU they all have more university. They have very talented people. If empowered with the right equipment, because what they need is the right equipment and the right materials to do research. When they write their proposal, and what they need, we need private takers on this, because the private takers will be very interested on what's going on, and they will want to get a better understanding what it takes to do it. So that, to me,
the question has been that, okay, first of all, of course, research in the United States, like the institution you work for, is not government funded. Here we look to government to fund. If it's KEMRI, it's government. When you carry, it is government. There must be alternative sources of funding.
That's what I said.
Is there investment in the private sector in research?
That's what I said. I'm coming back to Kenya very soon.
Yeah.
And we are trying with fellow colleagues, fellow scientists, to think of ways to bring in stakeholders into this business where people understand what it means. Everybody would like to see an institution, a private institution,
Yes.
that comes up with something that alleviates human suffering or saves human lives. You feel good about it. So my feeling is, if you can show people, be simple enough to tell them what you are doing and show them what are the pitfalls, and if they understand that, I think we'll find people coming in and try to invest rather than just the government.
Yes.
Having people in Kenya, I can tell you,
Yes.
there are people, there is money. We say there is no resources in this country. But when I go in the roads of Nairobi,
Yes.
there are bigger vehicles than I've seen maybe in Indianapolis. There are more Range Rovers in Nairobi than I've seen in Indianapolis.
Yeah.
So those people can come in, pitch in. But we as scientists, we have a responsibility. We need to simplify the message you want to deliver to them. Tell them this is exactly what I need to do. Because when you start a biochemical or a biopharmaceutical, biotechnology company, the first thing you start selling is hope. Hope that you're going to discover something that will do something great.
But people say
hope cannot pay your salary.
Exactly, exactly.
Well,
that science research
sharing
does
for-
not pay.
It doesn't
Sharing
For investors.
Sharing power, and people who made Repertoire
Yeah.
spent their money on hope, and their reward was enormous.
Yeah.
However, that hope has to be accompanied by some scientific information.
Promise.
Promise. You have to show people, why do I think I'm
Promise.
going to
There
be
has to be
successful?
promise.
I have to convince you. If I cannot convince you that I'm going to be successful, don't invest in me.
Yeah.
If I can convince you, I know how this virus moves, and I know if I stop this step, I'm going to stop it. And you can buy that, invest in me. If you don't believe in that, don't invest in me. That's what I would say.
Yeah. But again, most of that is usually, I may be wrong, but driven by philanthropic, what would I say, corporates that have succeeded or individuals who commit a bit of the resources towards science and research to benefit humanity.
No,
I mean, we have seen...
What is lacking here is, especially in my country, and I think we should do more.
Like Bill Gates, you know, philanthropists who have put out money out of success.
Right.
Is there hope in Kenya that...
No, I think there's hope. I think it's, again, as I said, well, a lot of people actually who invest in pharmaceutical companies, like in America, they are not philanthropists.
The
actually,
business
there are people who want to make money. And people actually, most of the companies that make money, they make it through the IPOs.
Yes.
Because I come up with an idea, I sell it to you, and you like it, and you invest in that. And some of them have made big money because they saw what would come out of it if it succeeded. You see, if it succeeds and makes a lot of money, or it, you know, that's one thing. Although as a scientist, I look more of the patient part, you know. I'm more of seeing the patients being treated. But that coupled with the fact that you can also, economically, you can make some money, it makes it a very promising prospect.
But in this company, do you have private company? In this country, do you have private companies doing that kind of research, like your company in America? Except Cambridge.
I think there's some. There's some companies which are doing, okay, of course, drug manufacturers. But whether they do much more, they do a bit of research, or they just manufacture drugs under patent.
Manufacturing is different from doing research. Research is coming with an entity.
Yeah.
There are two different things. Which one would differentiate? There's what we call invention.
Yes.
And there's also what we call innovation.
Innovation, yes.
And those two are different.
Yeah.
Invention is coming with something that was not there before.
Yeah.
Innovation is putting things in a different way,
modifying
things,
improving on
way,
those
and improving
upon
what existed.
Yeah.
And we need both coupled together.
Yeah.
Invention, we need more invention here, but we need empowerment because our researchers don't have resources of their own. They need to be empowered. But they need, the people empowering them need to understand what they are doing so that they can empower them.
Yeah.
So education part, I say, is very critical. That's why our universities, the University of Nairobi, the more universities, MKU, and others, should put that as a priority.
There is an issue here in this country about drugs and medicine, the real ones and the generic ones.
Yes.
Is there a problem with the generics?
Generics, there's no problem. The generics.
There's a difference between generics and fake.
Okay, that there is a problem.
Yeah,
well, it's generic and fake, because what happens after 17 years, when you discover a drug like Hepatitis,
yes.
you are given 17 years to sell. You can be the sole seller of that drug. Within that 17 years, nobody else.
Who gives the World Health Organization? Or
no, in this case, it's FDA, Food and Drug Administration.
In America.
Right. Now, in that 17 years, nobody should make that drug to sell.
Yes.
People can make it to do research and all other things, but they cannot make it to sell.
Right.
Now, after the 17 years, anybody now can make it if they can show that they can do it and have what we call bioequivalence.
Yes, yes.
They can do it.
All right.
So that's where, this is where the problem comes. When you write a patent, you have to stipulate step by step the best method to make
produce it.
If you don't, if you leave out some details, they can invalidate the patent. So for those 17 years, there are some people who are just practicing from what you've written in the patent, because it goes in the public domain.
Yes.
What you've said in that, they've been practicing and making it even better. And the thing is, they don't have overhead because they didn't have to use any money to do the discovery.
Yes.
So they're just using the information that you've provided. So after the 17 years are over, they just take your cookbook, the one that you provided in the patent,
yes,
and they don't have any overheads or anything. And that's why they can afford to sell it.
What if some country which does not believe in the intellectual property, like China, for instance? Suppose the Chinese go and take whatever you've written and make theirs and call it XYZ.
I would say now we are living in a global village. And
what would happen?
Well, they are, because of the international agreements,
yes,
we are seeing a lot of those international agreements coming into place, put into place. And we are seeing lawyers even from US going to India, going to China to follow those. It will depend on, if it's a small deal, they might, say it's not worth the effort of doing that. But if they think it's a big deal, they'll go there. And, that's something people, and that should not happen. We should be very, very careful, because the other thing I try to tell people, we should not do things that would kill the spirit of invention and innovation.
Yeah.
Because the moment you start shortchanging the process, the investors who discover that medicine, if they don't get their return, they are not going to put more money there. Yeah. And if they don't put, like HIV, for example, it's a disease that you get resistance.
Yes.
I don't know whether you understand how the resistance comes.
Yes, yes.
Now, when the resistance comes, you need a newer drug to fight that resistance.
Yes.
So you have to keep abreast with the disease.
Yeah.
And so if they don't make money with the first drug, they're not going to make another one
after that.
So you have to think very carefully what happens, the dynamics that take place.
Okay. Somebody has asked something they need to, you're going to have to dispense the medicine here today. We're opening a pharmacy. And this is, I thought I should raise this, because somebody says Clavulin, Clavulin, the medicine. I hope you know it. And is it used to treat hepatitis? That's one. And secondly, somebody says, I'm hepatitis B positive, and for 5 years I've been taking lamivudine. Yeah. But he's still, he's still positive. Are those two drugs, applicable for hepatitis?
Again, those are not drugs in my area. These are drugs in the other hepatitis. I'm more in hepatitis.
Oh, they're in the B not C.
But in any case, my take on those, if the drug doesn't work, a lot of drugs we make, sometimes they don't work. Yeah. One, because you might have a resistant strain.
Yes.
Even hepatitis C.
Yeah.
We don't cure 100% of patients who take it. It's maybe like 75 to 80%.
Right.
There are people who have resistance strains in them, and they are not being, these drugs are not effective. So what they need to do is being genotyped to see whether they have the resistant strain.
Okay, finally, there is always people thinking that, for example, if you had done this discovery or invention here in Nairobi, in Kenya, it would have been accepted that the research done in Africa, Kenya is looked down upon, and that, you know, you have to be out there to do research for you to excel. Acceptability of our inventions. And that draws back to 1989, Cameron, that Kenya had discovered HIV medicine, and then it was not accepted by the world.
Well, I don't think that's true, sorry to say.
Yeah.
If scientists live on data,
Yeah.
if you provide compelling data, people will buy into it. But if you just go there and say, my drug is treating this disease, and you don't have data. For example, when we did Hepatitis, we had to have two groups. One that was given the medicine, and these were blind. We didn't know who was getting what. So we have a group of people, half of them are getting a capsule with a drug, and half of them are getting a capsule with just the powder, no drug. We call it placebo. Their own given codes. Nobody knows who got what. Even the patients don't know who got what. After the end of the experiment, after the end of the clinical trials, an independent group breaks the code and looks at the results. And they look, if some drugs actually, you find people who are given placebo, they're doing better than people who got the drug. But if the drug is effective, statistically you find the numbers will be so good for people taking the drug, and you do statistics to show that placebo was much worse. No, some people by faith will be cured anyway, but very low percentage. But people who got the drug will be cured. So if you have a compelling data like that, there's nobody who's going to say, I'm not going to buy or take this drug.
Okay.
But when you go there, you know, and those are issues we've seen before, just say my drug is, I treated so-and-so and he's cured. You know? I mean, you don't know.
So in short, there is a professional respect, as long as data can support it.
Exactly.
It doesn't matter whether you're in Malaysia, Nairobi, or New Jersey.
And I've been going around the world. I've gone to other countries. And I've gone to do what we call due diligence. Okay. To see what they've been doing, and because sometimes we do get engaged some collaborators from small, young companies that are growing. They cannot develop the drug all the way to the market. So we go looking for them. And I see some of them, you know, even in India, in Germany and other places, very small companies. And when we see the data, and it's compelling data, it's not, if we don't take that, somebody's going to come and take it, and, you know, the returns are going to be great.
Finally, future. You said you're coming back home. What are you intending to do? Retiring back home? And what other research are you working on currently, if it's not a secret?
Okay, well, my intention is when I come back to Kenya to try and mentor some of the young scientists in the area of drug research and nurture them such a way we can lay a foundation for some form of a biotechnology. As you said, we don't have drug discovery efforts that I am aware of. There could be some that I'm not aware of, but I don't know, especially in Kenya, maybe South Africa, but I don't know of any company that's doing drug discovery. So I would like to talk to people, see their interest, and as I said, try to educate them in what we've done before and tell them what we can do, what areas of disease we can tackle, and perhaps bring a team and have maybe a life science center where we could be doing different drug discoveries, maybe at a lower level, or also as a collaboration with the United States, because I have a lot of collaborators there, and also in China and other places. So that's my dream.
All right.
Okay. So.
Thank you so much, Dr. George Njoroge, trained at Nairobi University in the United States, and was on Friday awarded an honorary degree in pharmaceutical sciences by the Mount Kenya University during the graduation ceremony held in Thika here among the graduates. Dr. Njoroge, of course, was honored in 2011 with the Hero of You call it the heroes of chemistry. That's the hero, the Hall of Fame, in the area of chemistry.
Yes.
A great achievement for Kenyan scientists out there and back home to be recognized. We thank you for watching. Today is World Hepatitis Day. That is why we're focusing on that, and we had the privilege of having the honored scientist with us this morning. Keep watching Power Breakfast.
Thank you. Thank you. Thank you, Citizen.